In October 2025, a strange object appeared in the sky above Mars. A faint, glowing visitor moving on a path from beyond our solar system was spotted by orbiters from NASA, ESA, and China. Immediately, a global observation network was activated. Telescopes on Earth and spacecraft at the Red Planet united to watch this historic event. The object, known as 3I Atlas, challenged everything scientists thought they knew about physics. Observatories launched a global campaign, determined not to miss a single moment. And when the first images were sent back, they left the scientific world in shock. Was it just an ancient comet or something sent from a distant civilization? In October 2025, a faint light appeared above the horizon of Mars, cutting through the thin orange haze of its sky. At first, the signal seemed ordinary, just another streak among thousands of dust reflections recorded by orbiting spacecraft. But when scientists zoomed in, they realized the light wasn't coming from Mars at all. It was moving far beyond the planet, tracing a slow and deliberate path across space. The object soon received a name that would capture the world's attention: 3I Atlas, the third interstellar visitor ever discovered by humankind. Unlike any comet or asteroid seen before, its origin lay outside the solar system, and its behavior defied everything astronomers expected. Most comets fall toward the sun, pulled by gravity into long looping arcs. 3I Atlas, however, moved freely, following a hyperbolic trajectory that meant it would never return once it passed. From that moment, every telescope on Earth turned toward the skies to watch this mysterious traveler. For the first time in history, both humans and machines on two different planets would witness an object from another star system. Its faint glow over Mars marked a turning point, proof that our solar system is not isolated but open to visitors from the deep unknown. If this was only the beginning, then the real question was, what secrets this traveler carried as it drew closer to the inner planets? By early July 2025, scientists around the world were studying a new entry in the Minor Planet Center database, an unidentified object labeled a 10SN12, later named 3I Atlas. It quickly drew attention for its abnormal speed and trajectory. Calculations showed that it was moving at about 134,000 miles per hour, faster than any asteroid ever observed in the inner solar system. Its motion didn't fit any known orbital pattern. The numbers pointed to a hyperbolic path, meaning the object was not captured by the sun's gravity. It would enter our system once and then continue back into interstellar space. For astronomers, that alone made it historic. The International Astronomical Union officially confirmed its status as the third interstellar object after Oumuamua and 2I Borisov. But 3I Atlas immediately showed features that set it apart. Unlike the two earlier visitors, which were small and faint, this one was massive, with an estimated core diameter of 5 kilometers and a total mass exceeding 30 billion tons. Its dark surface reflected only 4% of the sunlight that hit it, suggesting it was coated in a layer of carbon-rich material or possibly metal oxides. Such low albedo levels are usually seen in inactive comets that have traveled for millions of years through deep space. Even more intriguing was its direction of origin. When scientists traced its inbound route, it appeared to come from the region of the Hercules constellation, yet there were no nearby stars capable of ejecting such an object. Some researchers proposed that it might have drifted through multiple star systems before reaching ours, gathering layers of interstellar dust along the way. Others speculated that gravitational interactions with unseen planets or rogue stars could have redirected it toward the sun. As word spread, a massive coordination effort began. Ground-based observatories across Chile, Australia, and the Canary Islands synchronized their instruments to capture every movement. Space agencies joined forces in what came to be called the Interstellar Watch 2025, pooling real-time data from both hemispheres. For the first time, astronomers had the chance to monitor an interstellar body continuously from entry to exit, and as orbital models improved, one unexpected detail emerged. The object's trajectory would bring it closer to Mars than anyone had anticipated, just 30 million kilometers away, close enough for active spacecraft to observe it directly. It was an opportunity no one wanted to miss. The next phase of research would move beyond Earth's telescopes and into Martian orbit, where the first close-up data on this interstellar traveler would soon be captured. But could Mars truly reveal what 3I Atlas was made of, and why it seems so different from everything that had come before? By early October 2025, all eyes turned toward Mars. Astronomers had confirmed that 3I Atlas would pass within observation range of the red planet, and for the first time in history, humanity prepared to study an interstellar object from another world. The European Space Agency, ESA, led the mission, activating two orbiters, the ExoMars Trace Gas Orbiter, TGO, and Mars Express, to capture every possible frame of its approach. At a distance of about 30 million kilometers, both spacecraft began tracking the object with their high-resolution imaging systems. The CASIS camera aboard TGO detected a faint white speck surrounded by a thin haze, which scientists later identified as the coma, a cloud of dust and gas that forms when a comet warms as it nears a star. But something about this one was different. Its coma was dim and compact, unlike the large glowing tails usually seen on active comets. That detail hinted at a possibility that excited and puzzled scientists at the same time. 3I Atlas might not have fully awakened. It could have been in deep freeze for millions of years, its surface sealed tight by radiation exposure during its long journey through interstellar space. As it entered the sun's influence, the heat wasn't enough to trigger the violent outgassing seen in normal comets. To confirm this, scientists compared the readings from Mars to data captured by Earth-based telescopes. The results were strikingly consistent. 3I Atlas showed a stable brightness curve, meaning it wasn't shedding much material. It was behaving almost like a solid body, more like an asteroid than a comet, yet its light spectrum showed traces of volatile gases. That contradiction became the mission's biggest mystery. Meanwhile, on the Martian surface, NASA's Perseverance rover and the Ingenuity helicopter were quietly collecting sky footage from Jezero crater. For several nights, the rover's navigation cameras caught a tiny moving streak in the upper atmosphere, just bright enough to be noticed. When those images reached Earth, social media exploded. Amateur astronomers zoomed in on the faint line, claiming it looked like a massive cylindrical object. NASA quickly released a statement explaining that the shape was the result of motion blur, created when hundreds of frames were stacked to form a long exposure. Still, the moment marked a milestone. These were the first ever images of an interstellar object taken from the surface of another planet. Even if the picture was small and noisy, it symbolized the expansion of human observation beyond Earth. ESA engineers continued to adjust the orbiter's cameras, running long exposures and collecting spectral data every few hours. Each dataset revealed new details. The object's outer layer reflected slightly more infrared light than expected, suggesting a thin coating of organic material. If true, it could mean that 3I Atlas carried carbon-based compounds, the same kind that serve as building blocks for life. The discovery reignited debates across scientific communities. Could such interstellar visitors have been the carriers of early biological ingredients? Could life on Earth, and possibly elsewhere, have begun with fragments like this, drifting between stars? As 3I Atlas moved deeper into the inner solar system, the data kept coming, but so did the questions. If the comet's surface was truly organic, what else might be hiding beneath that frozen shell? And was this the first step toward understanding where we really come from, or the beginning of a mystery even greater than life itself? By the end of October 2025, astronomers finally had enough data to study the true chemistry of 3I Atlas. The numbers they saw were unlike anything found in our solar system. Spectral analysis from both the ExoMars orbiter and Earth-based telescopes revealed that 3I Atlas was dominated by carbon dioxide and carbon monoxide, with almost no sign of water ice. This finding alone changed how scientists viewed its origin. Comets from our solar system usually contain frozen water as their main component, yet this one was made almost entirely of volatile carbon compounds. That composition suggested 3I Atlas had formed in a region far colder and more remote than the Sun's influence, perhaps in the outer disk of another star system or even inside an interstellar molecular cloud. The ratio of CO2 to H2O was measured at roughly 8:1, a chemical balance impossible to maintain near any warm star. To scientists, this meant the comet had spent billions of years traveling through a place where sunlight never reached, preserving its original chemistry since the birth of its parent system. Microscopic analysis of its surrounding dust showed another unusual property: negative polarization. This optical effect meant the dust particles were dense and reflective, made of complex materials rather than the fragile, porous grains typical of ordinary comets. Their surfaces appeared coated with layers of carbonized minerals that had been altered by cosmic radiation over immense periods of time. These grains reflected light unevenly, creating a spectrum curve that did not match any known class of comet or asteroid. Infrared measurements confirmed that the object's surface temperature was colder than predicted, suggesting an insulating crust that trapped heat inside. This crust could have been created by the slow evaporation of carbon compounds during its long journey through space, forming a kind of hardened shell. The inner material, however, remained a mystery. Some spectral signatures indicated traces of nickel and magnesium, but surprisingly, there was little to no sign of iron. On Earth, metals like nickel and iron are usually found together, but 3I Atlas seemed to defy that rule. Such a pattern hinted at a chemical separation process that may have taken place under extreme pressure or heat, perhaps when a young planet or moon was destroyed long ago. Other researchers propose that its chemistry could have been shaped by interstellar radiation chemistry, where high-energy particles gradually rearrange molecules into new forms never seen before. The result was a body that was both ancient and chemically alien, containing compounds stable enough to survive the harshness of deep space. Organic traces were also detected, not in the form of life, but as complex carbon chains, similar to those found in meteorites and interstellar dust. These molecules, known as polycyclic aromatic hydrocarbons, are considered precursors to amino acids, which in turn form the foundation of proteins. The presence of such compounds suggested that 3I Atlas carried the same basic ingredients that once seeded planets like Earth. To many in the scientific community, this was the most important revelation. It meant that interstellar objects might not just be random wanderers, they could also be messengers of chemistry, spreading the elements of life from one star system to another. 3I Atlas, with its frozen gases, carbon-rich surface, and metallic heart, had become a living record of cosmic history, a molecular time capsule from a place where our understanding of chemistry and creation no longer applies. And for the first time, humanity could study that record in real time, watching as the oldest materials in the galaxy passed silently through our corner of space. As 3I Atlas drew closer to the Sun, its behavior grew stranger. Telescopes from Mars and Earth recorded faint but regular pulses in its brightness, a rhythmic pattern that astronomers called a heartbeat. The cycle was too quick to match a comet's normal rotation, suggesting that something inside the object was influencing how it emitted or reflected light. Typical comets brighten unevenly when sunlight heats their surfaces and gas jets burst outward, but 3I Atlas stayed perfectly balanced. Its glow rose and fell in smooth intervals, as if its surface were regulating energy instead of reacting to it. The coma surrounding its core added to the mystery. It was thick, opaque, and unusually compact, hiding the nucleus completely from view. No long tail stretched across space as in ordinary comets. Instead, the object formed a spherical halo of ionized plasma, a glowing bubble that clung tightly to its body. Spectrographic readings showed charged particles trapped within this shell, hinting at a faint magnetic field strong enough to contain its own dust and gas. It behaved more like a self-contained system than a fragment of ice. Then, at the end of September, a coronal mass ejection from the Sun slammed directly into it. The blast of charged plasma should have shattered a comet of its size, yet 3I Atlas survived untouched. Its brightness rose slightly for several hours, then returned to normal as if nothing had happened. The event shocked scientists and earned it the nickname the Unbreakable Comet. Computer models later showed that its outer crust might be made of carbon-rich minerals mixed with heavy metals, forming a natural armor capable of absorbing solar radiation. Compared with the two earlier interstellar visitors, it stood in a category of its own. Oumuamua tumbled like a flat rock, flashing sunlight with every spin, while 2I/Borisov behaved like a normal comet, venting water vapor and leaving a vast dust tail. 3I Atlas did neither. It was heavier than Oumuamua, more compact than Borisov, and moved with near-perfect stability through the inner solar system. Its light curve remained smooth, its plasma shell unbroken, its symmetry precise. Every force that should have disturbed it, solar wind, radiation, or gravity, failed to change its shape or path. To many scientists, it looked almost engineered in its perfection, though clearly natural in origin. That balance made 3I Atlas one of the most baffling interstellar objects ever observed. It didn't just redefine what a comet could be, it forced astronomers to reconsider what kinds of matter can survive the harshest corners of the universe. By early October 2025, 3I Atlas had become the most closely studied object in the solar system. NASA, ESA, and China's space agency were all tracking it, feeding daily updates to the public. Then, without warning, that stream of information went silent. Between October 3rd and 6th, all three agencies paused their data releases, calling it a synchronization period. The blackout came exactly when the object was nearest to Mars, the most critical moment of the entire mission. Independent researchers quickly noticed that even open-access data portals were locked. ESA's ExoMars camera feed froze, NASA's telemetry servers went offline. And in China, the National Astronomical Observatories, NAOC, quietly restricted access to radio logs from the FAST telescope, the world's largest single-dish radio antenna. FAST had been scanning 3I Atlas for weeks, searching for low-frequency emissions. On October 4th, it reportedly detected a narrow-band pulse near 1.42 GHz, the same hydrogen line frequency often used in deep space communication studies. A short technical report mentioned the signal was rhythmic and inconsistent with background noise. Within hours, that report disappeared from public servers. Officials later said it was likely interference from local transmitters, but the data remained offline. At the same time, China's Tianwen-1 Mars orbiter and the Zhurong rover stopped transmitting images. For the first time, Beijing's usually open Mars mission provided no updates. The silence from all three powers, the US, Europe, and China, created global confusion. Amateur astronomers tried to fill the gap. A user named Drew C. shared a stacked image of a diagonal streak near Mars, claiming it matched 3I Atlas's path. His post went viral, fueling theories that the object might be emitting light or energy instead of reflecting it. Scientists dismissed those claims, but they couldn't explain why official data stayed restricted. Inside research circles, coordination meetings were held across Harvard, JAXA, and the European Southern Observatory. Sources said the blackout was for data calibration, not secrecy. Teams were verifying overlapping signals from multiple instruments. Still, to the public, the synchronized silence looked suspicious. For nearly 4 days, no one could access detailed readings from Mars or Earth. When the data finally returned online, it contained only positional updates and one short sentence: 3I Atlas remains stable. No charts, no spectral graphs, no mention of radio findings. Whatever had been discovered during those missing days, the world's most powerful observatories had all chosen to stop speaking at the same moment. And for many watching from Earth, that silence said more than any official report ever could. Astronomers around the world are turning their attention to what would come next for 3I Atlas. The object was racing toward its perihelion, the point closest to the Sun, and no one knew what might happen when it got there. Some comets flare dramatically and disintegrate under the heat, while others survive unchanged. This was humanity's first chance to watch an interstellar visitor face that test in real time. NASA scheduled the James Webb Space Telescope and the Subaru Telescope in Hawaii to monitor the comet's final approach. At the same time, the Gemini South Observatory in Chile prepared to collect near-infrared data, hoping to detect changes in its chemical composition as it heated. In Europe, ESA redirected its JUICE spacecraft, originally bound for Jupiter, to record additional light measurements as it passed through the outer regions of Mars's orbit. Even Japan's JAXA joined in, proposing to use its Comet Interceptor mission to study 3I Atlas's behavior and design strategies for the next interstellar visitor. Every major observatory on Earth was now aligned on one goal: capturing as much information as possible before the object disappeared forever. Simulations predicted that by early 2026, 3I Atlas would slingshot out of the solar system and head toward the Lyra constellation, carrying the story of its brief encounter with humankind. The data gathered during those weeks would allow scientists to map the exact structure of its coma, track its mass loss, and test new models of interstellar chemistry. For the first time in history, a celestial object was being watched simultaneously from Earth, Mars, and deep space, a global experiment connecting the entire scientific world. And yet, even with all those eyes fixed on it, one question remained: would 3I Atlas reveal its secrets before it vanished into the dark once again? As 3I Atlas disappeared into the darkness of space, scientists realized its true legacy had just begun. For astrophysicist Suzanne Falsner from the Max Planck Institute, this interstellar traveler could be a planet seed, a solid fragment that helps new worlds take shape when it drifts into a young star's dust cloud. If that theory is right, then every planet, even Earth itself, might have started with a visitor like this. It means the story of life could be written not just within one solar system, but across the entire galaxy. Meanwhile, Avi Loeb from Harvard took a very different approach. He suggested that 3I Atlas might be a technological artifact, a relic of advanced engineering that survived the void between stars. To him, its perfect balance and resistance to radiation might not be coincidence, but design. These two views, one biological and one technological, reflect humanity's oldest question: are we the creators or the created? But beyond philosophy, 3i Atlas has sparked something practical. It showed how limited our current tools still are when facing visitors from deep space. That is why the world's leading space agencies are already preparing for the next encounter. NASA and ESA are developing next-generation telescopes like the LUVOIR and HABEX missions, designed to spot interstellar objects the size of a house from billions of miles away. The Vera C. Rubin Observatory in Chile will soon begin scanning the entire southern sky every few nights, capable of detecting faint, fast-moving objects long before they reach the inner solar system. Japan's Comet Interceptor project is building a spacecraft ready to launch on short notice, waiting in orbit to chase the next visitor across space. And new satellites equipped with infrared sensors will soon watch the sky around the clock, allowing us to detect objects even in the glare of the sun. These efforts mark the start of a new era, one where we don't just wait for the unknown to find us, but go out to meet it. Because if 3i Atlas truly carried the seeds of planets or the fingerprints of intelligence, then the next one might hold the answers we've been searching for all along. For the first time in history, humanity captured clear images of an interstellar object not from Earth, but from spacecraft orbiting Mars. That glowing dot, known as 3i Atlas, united the world's observatories in a single mission: to watch, to learn, and to wonder. Across continents, telescopes turned their gaze toward the same point in the sky, marking a rare moment when science felt like shared discovery. But this is only the beginning. The mystery of 3i Atlas reminds us that the universe is still full of travelers, messages, and unknown worlds waiting to be found. And next time, we might be ready, not just to observe them, but to reach out and meet them.